This video describes the design and manufacture of this rotating tailstock for my lathe. This rotating tailstock has a 1 1/4 inch by 8 TPI thread, and it rotates. And I use it for two major applications. The one application is for gluing up segmented rings on my lathe, where I have maybe my base plate. It's been mounted on my headstock. I mount this secondary disc on my tailstock with one of these rotating tailstock adapters. Then I could line the two up, get it perfectly aligned, glue them up, and then glue them in place. And the advantage of this is the disc will no longer slip and slide. They're perfectly aligned and everything will be symmetrical. So that's a great technique for gluing up segmented disc. And I end up with projects such as this, with multiple layers of segments. The other application was making some of my segmented eggs, where I was turning this egg on the lathe, on the headstock, getting this side all done. Then I would take the chuck off the lathe on the headstock, reverse it over, attach it to my rotating tailstock, put a vacuum chuck on my headstock, clamp it in place. That way everything's perfectly aligned, perfectly centered, and then I can turn off this side, and as soon as it's turned off I can pull this away and then finish the bottom of the egg. So it's a great technique for doing round segments, projects such as this egg, or some of the other projects I've made in the past. This is my original rotating tailstock that I purchased more than 10 years ago, and I use this in numerous videos. And customers that have seen these videos have often asked, where did I get this, because they weren't able to find it. So I did an extensive search on the web, and again, apparently it's not available anymore. The tailstock with a 1 inch by 8 TPI threads is available from multiple suppliers, but the 1 1/4 inch 8 TPI threads is no longer available. So I decided I would need to make this. So this is my version I came up with. It actually consists of two components. The first part is this stainless steel #2 Morse taper with this rotating head. Originally I thought I would manufacture this entire assembly as one whole piece in my shop, but I was able to find this on the web, and I can purchase this for less than $50, and I couldn't make it for that, so it made sense just to use this and then make a head to adapt to it. So that's what I'm doing. So this is the stainless steel #2 Morse taper, which will slide right into your tailstock on the lathe, and this pin here rotates. Then I machine these headpieces. This is machined from aluminum. It has a 1 1/4 inch by 8 TPI thread head on it, and the opposite has a hole which will slide over the pin on this rotating tailstock. And then it's held in place with a set screw. And then that rotates on this adapter. So this video will describe the machining of this 1 1/4 inch by 8 TPI head out of aluminum, and then assembly the two components. Then I'll be demonstrating this on my lathe that I use for machining various projects. The rotating tailstock adapter headpiece was designed using the Fusion 360 software. This headpiece will be machined from an aluminum stock material that will be 1 1/2 inches in diameter by 2 inches long. The top section of this aluminum stock will be threaded with a 1 1/4 inch diameter by 8 threads per inch thread to a length of 0.9 inches long. At the base of the threaded section are two recesses. The top recess is 1.04 inches in diameter by 0.125 inches in length for the bottom clearance of the threads. The second recess is 1.24 inches in diameter by 0.15 inches in length to engage with the various chucks and faceplates that will later be attached to this headpiece. On the opposite side of the headpiece, a 0.750 inch diameter hole will be drilled to a depth of 1.25 inches. The Fusion 360 software is then used to generate the programming code for the CNC lathe in order to machine this component. I'll be using 3 metalworking machines in my shop to turn these rotating tailstock adapter headpieces. For this first operation, I'll be using my manual lathe to face off the two surfaces of the 1 1/2 inch diameter by 2 inch long 6061 aluminum stock piece. This provides for flat and parallel surfaces on both sides of the 1 1/2 inch aluminum stock piece. Next, I'll be using a 5/8 inch diameter drill to drill a hole about 1 1/4 inches deep on one side of the aluminum block. This hole will later be enlarged to an inside diameter of 0.750 inches on my CNC lathe in order to tightly fit onto the pin on a rotating adapter. Next, I'll be using my Tormac CNC lathe. There will be two separate setups, one for each end of the aluminum block, and I'll be using 5 different tools for the machining of this rotating tailstock headpiece. For the first step, I'll begin by resurfacing the front face of the aluminum block and then turning the outside diameter down to 1.45 inches. I then change the tool to a boring tool to machine the inside diameter of the previously drilled hole to a precision inside diameter of 0.750 inches. Next, I reverse the aluminum block in the lathe headstock in order to machine the opposite end of the headpiece. Once again, I resurface the front surface of the aluminum block. I then turn down the outside diameter aluminum block down to 1.25 inches, which will be the outside diameter of the threaded section of this headpiece. I also machine the recess at the bottom end of the threaded section. Finally, I machine the 1¼ inch by 8 threads per inch threads on the aluminum block. This operation required numerous steps, each step moving the turning tool end between 0.02 and 0.05 of an inch to achieve the required depth of the thread and not to overburden the lathe. And here is a finished machined aluminum headpiece for the rotating tailstock. I also tried turning these parts out of steel. However, this proved to be a challenge for my CNC lathe. I was encountering problems when trying to turn the very coarse and very deep 8 threads per inch threads. The final step was to drill and tap the holes for the set screws in the aluminum headpieces. This was done using my CNC mill. I first used my 3D printer to print out some custom designed jaws for my mill vices. These plastic jaws hold the aluminum headpieces without scoring their outside surfaces. I then used a .201 inch diameter drill to drill a hole in the side of the previously machined aluminum blocks. I then tapped the 1/4 inch by 20 thread per inch holes using the thread milling techniques on my CNC mill. And this is the finished machined headpiece for the rotating tailstock. It just requires some additional deburring of the corners and edges. I'll be demonstrating 2 applications for the use of the rotating tailstocks on my Powermatic lathe. Both of these applications were performed with my original rotating tailstock, but the results will be the same for the rotating tailstock which was developed for this video. Both of these applications were taken from a recent video on the production of the segmented wood Pasanki eggs video entitled The Russian Stranglehold on Ukraine. The first ring for the segmented Pasanki egg is a segmented disc with 18 wedges or segments going to a perfect point in the center. I'll be gluing this segmented ring base plate to a wood block which was mounted to the lathe faceplate on the headstock of the lathe. The rotating tailstock was attached to the tailstock on the lathe, and a small chuck was screwed into this rotating tailstock. The segmented base ring was then clamped into this vise. When the segmented base ring is pushed up against the faceplate on the lathe headstock, this ring will be perfectly aligned with the lathe headstock. This technique will ensure the perfect alignment of this base ring as well as all subsequent segmented rings. For this project, the additional segmented rings were previously glued together using some alignment jigs to center each of the rings with one another. This glue and alignment technique was described in my previous YouTube video on the segmented Pasanki egg project. This assembly was then attached to the chuck on the rotating tailstock on the lathe tailstock. After glue has been applied, the segmented ring assembly is pushed up against the previously attached base segmented ring on the lathe headstock. Because both the segmented ring mounted on the headstock and the disc assembly mounted on the rotating tailstock can be freely rotated, the 2 sections can be perfectly aligned with the joining segments offset by half a segment. At the same time, both segment ring assemblies will be symmetrically aligned with the center axis of the lathe. This shows the Pasanki egg project mounted on the lathe headstock. The entire top section of the segmented egg has been fully shaped and sanded, and I now need to turn the opposite side or bottom half of the segmented egg. So I unscrew the faceplate on the lathe headstock with the segmented egg still attached. I then attach this faceplate to the rotating tailstock on the lathe tailstock. I next attach a vacuum chuck to the lathe headstock and push the segmented egg into this vacuum chuck and turn on the vacuum. Since the segmented egg is mounted in the headstock vacuum chuck while it is still attached to the rotating tailstock, the perfect alignment of the segmented egg is assured. I can then proceed to turn the bottom half of the egg, cut it off from the faceplate, and finish turning and sanding the bottom half of the segmented egg. This concludes this video on the new 1 1/4 inch by 8 thread per inch rotating tailstock adapter. This item is now available on our website. The part number is AST125-8. This rotating tailstock includes a stainless steel No. 2 Morse taper mount with a 1 1/4 inch diameter by 8 thread per inch rotating threaded headpiece. Currently this headpiece is machined from aluminum, but I'm currently working on a machined stainless steel threaded headpiece which should be available shortly. Once again, thank you for watching this video. If you have any questions, concerns, or comments, as always, please give us a call or drop us an email. And thank you for watching.